You know when you use a translation app on your phone and it's just shockingly good? Like you can throw a whole paragraph at it and boom, it spits out a near perfect translation? Well, the secret behind that little piece of everyday magic is an amazing story. It's about one brilliant idea that taught computers how to do something incredibly human, how to pay attention. I mean, we totally take it for granted now, right? But it's worth remembering that for a long, long time, AI translation was, well, it was clumsy. It was awkward. You kind of got the general idea, but you'd never rely on it for anything important. So what was the huge breakthrough that changed everything? The answer lies in solving a really specific problem, a memory problem. You see, the whole issue was that these early AI models had a shockingly bad memory, especially when you gave them long, complicated sentences. The way they were designed basically forced them to pull off this impossible memorization trick, and as soon as the sentences got longer, the whole system would just start to break down. So the old system had this pretty simple two-part setup. First, you had an encoder that would read the entire original sentence, say in English. Then a decoder would try to write the translation in French. Sounds simple enough, right? Read and write. But the way they passed information between them, oh man, that was the source of all the trouble. Okay, so this is where the design gets kind of wild. The encoder was forced to squash the entire meaning of a sentence, I don't care how long it was, into one single fixed-size chunk of data. I want you to imagine reading an entire novel, and then someone tells you to summarize the whole thing, every plot point, every character, into a single sentence. Now, imagine someone else has to rewrite that entire novel perfectly based only on your one-sentence summary. All that nuance, the subplots, gone. That is the insane information bottleneck we're talking about here. And here it is from the researchers themselves. They said the AI had to compress all the necessary information of a source sentence into a fixed-length vector. That fixed-length vector, that was the prison. For a tiny little sentence like, I love cats, sure, it worked okay. But for anything longer, crucial information was just getting lost in the squeeze, and the translations would completely fall apart. So this bottleneck was holding back the entire field. The problem seemed baked into the architecture. But then in 2014, a team of researchers led by Dzmitry Bahdanau came along with a breakthrough idea, an idea that would completely change the game. Just think about how a real human translator works. You don't memorize an entire page and then start writing from memory, right? Of course not. You look at a phrase, you translate it, and then you'll glance back at the original text for the next bit. So the researchers asked a simple question. What if we could let the AI do the same thing? What if we stopped asking it to be a memory champion and just let it look? And they called it the attention mechanism. Instead of that one compressed summary, this new method gave the AI the power to look at the entire original sentence at every single step of the translation. Using this really clever scoring system, it could figure out which words in the original text were the most relevant for generating the very next word of the translation. It could literally pay attention to what mattered at the exact moment it mattered. Okay, this sounds amazing in theory. It's a really elegant solution. But the million-dollar question is, did it actually work? Well, the results are what made this paper absolutely legendary. So let's put them head to head. The old way is static. It's rigid. You get one compressed summary for the whole sentence, one size fits all. But the new way, with attention, is totally dynamic. For every single word it writes, it creates a brand new, custom point of focus, intelligently deciding which part of the original sentence it needs to look at. And here's the proof in the pudding. This chart shows how well the models did on long sentences. We're talking 50 words or more. The old model, the one without attention, its performance completely tanks. It just falls off a cliff. But the new model with attention, the one they called RNN search, it stays strong. It stays consistent. The bottleneck was officially broken. Just as the authors wrote, this new architecture made translating long sentences far more reliable. Look, they didn't just make a small improvement here. They fundamentally solved the biggest problem that was holding back machine translation for years. But fixing the long sentence problem wasn't even the only breakthrough. No, maybe the most incredible part of all of this was that for the first time, the attention mechanism gave us a window into the AI's mind. We could actually visualize what the AI was looking at while it worked. Okay, check this out. Along the bottom, you've got the original English sentence, and going up the left side, that's the French translation being generated, one word at a time. Each bright pixel shows you which English word the AI is focusing on to produce a specific French word. And what do you see? This beautiful, clean diagonal line. It means as the AI is writing in French, it's just moving across the English words in pretty much the same order. It's so logical, so intuitive. But this is where it gets absolutely mind-blowing. In English, we say European Economic Area. But in French, the grammar flips the order to Zone économique européenne. Now look at what the AI does. To write zone, it looks at area. To write économique, it jumps back to economic. And for European, it zips all the way back to European. It's not just translating word for word, it's correctly understanding and applying grammatical rules to reorder the phrase on the fly. I mean, that is incredible. And it gets even more subtle. To translate the man into l'homme, the AI has to pick the right French article. Is it le, la, or le? That choice depends on the noun that comes after it. And you can see it happening right here. To generate le, the bright spots show the AI is paying attention to both the and man at the same time. It's using context from multiple words to make a smarter decision. It's this soft, flexible focus, just like a human would use. So you can see, this wasn't just some clever trick for better translation. The idea of attention turned out to be one of the most important breakthroughs in modern AI, with consequences that rippled out way, way beyond just language. At its core, it completely broke the memory bottleneck. By freeing AI models from that prison of the fixed-length vector, it allowed them to process much longer, much more complex streams of information than ever before. This one idea just unlocked a tidal wave of new possibilities. So what are the big takeaways here? First, the attention mechanism solved that critical long sentence problem that had stumped AI translation for years. Second, it gave us this incredible new tool to actually peek inside the black box and see what an AI is doing. And most importantly, this concept became a foundational building block for pretty much everything that came next. Yeah, I'm talking about the large language models like GPT that we see everywhere today. And that leaves us with one final fascinating thought. These researchers taught an AI to pay attention to words in a sentence. But what else could this idea be used for? What about teaching an AI to pay attention to the most important pixels in an image, or the keynotes in a piece of music, or the critical data points in a huge scientific experiment? This one simple, elegant idea didn't just improve translation, it opened the door to a whole new way of building intelligent systems. And we are still just scratching the surface of what's possible today.